Matatag Curriculum, Science 4, Quarter 1, Lesson 4, Materials and Their Uses. For the learning competency, describe changes in properties of materials when exposed to certain changes in temperature, such as changes when wood or coal is burned. Learning objectives. Describe changes in matter that involve physical change and chemical change. Investigate to show how changes in properties of materials occur when exposed to very high or very low temperatures. Cite situations wherein phase change is beneficial. For day 1. For the short review, complete the table below by describing the characteristics of solids, liquids, and gases. Let us now answer. For solid, its characteristics: solids hold their shape, they do not flow, and do not take the shape of their containers. Examples: paper, coins, books, and pencils. For liquid, liquids are objects that flow. They take the shape of the containers that hold them and fill the container starting from the bottom. They do not float, and they can be held in a container even with an open lid. And for its examples, we have water, oil, and alcohol. For gas, gases take the shape of their containers. When placed in a container with an open lid, gas particles will go out or escape the container. Gases are usually light and can float around in space. Many gases cannot be seen. Its example is air. Matter. Matter undergoes various changes when exposed to changes in temperature, which can be classified as either physical or chemical. In the next phase of the lesson, you will be able to know and understand how these changes in matter happened. It could be a change in its internal structure or physical appearance. It may also result in the formation of new materials when they are mixed. We will play Unscramble word game. Directions: rearrange the letters to create a word corresponding to the word given. For the meaning, it is to make or become different. The answer is? You're right, it is change. For the second one, its meaning, it is a measure of how hot or cold something is. The answer is? Very good, it's temperature. For the third one, it is a type of food with a limited shelf life if it's not refrigerated. You're right, the correct answer is perishable. Next, it is a process in which one or more substances, the reactants, are converted to one or more different substances, the products. Very good. The right answer is chemical reaction. Next, it is the chemical reaction that occurs between substances when materials burn. What is the right answer? You're right, it is combustion. One of the changes that can happen in matter is a state change. A solid object can turn into a liquid or a gas. A liquid can turn into a solid or a gas. Last, gases can turn into liquids or solids when exposed to very high or very low temperatures. These changes happen to materials, and it is what we call physical change. While the ice is melting, the temperature increases. The ice absorbs heat energy from its surroundings, causing its molecules to gain energy and move more freely, thus changing from a solid to a liquid. Same substance, water, can exist in different states of matter, depending on the temperature. This is applicable not just to water but to many other substances as well. Take a look. What is the current state of the ice cubes? Number 2 question. Can you describe the properties of the ice cube? Example given, solid, cold to touch. What changes do you observe as the ice cubes are heated? What is happening to the ice cubes as they start to melt? Can you describe any changes in the appearance or texture of the ice cubes? Let us now answer the questions. For number 1, what is the current state of the ice cubes? You're right. The ice cubes are currently frozen and solid. For the second question, can you describe the properties of the ice cubes? Example given, solid, cold to touch. Very good. The ice cubes are cold to touch and have a solid texture. For number 3, what changes do you observe as the ice cubes are heated? Exactly. As the ice cubes are heated, they start to melt and become smaller. Number 4, what is happening to the ice cubes as they start to melt? Very good. As the ice cubes melt, they start to turn into liquid. Number 5, can you describe any changes in the appearance or texture of the ice cubes? You're right, the ice cubes become wet and lose their solid shape as they melt. Day 2. Melting. It is a process where a solid turns into a liquid when it gets warm enough. When something melts, it becomes soft and turns into a liquid. For example, when ice cream melts, it becomes liquid instead of being hard like ice. Here are the examples of melting. We have ice melting. One common example of melting is when ice cubes are left outside on a warm day. As the sun shines on them or the temperature gets warmer, the ice cubes start to melt and turn into water. Second one is chocolate melting. Another example is when you heat chocolate in a microwave or over a stove. The solid chocolate turns into a liquid, making it easier to spread or use for making desserts like chocolate-covered strawberries. Next is candle wax melting. When you light a candle, the heat from the flame melts the wax. The melted wax then drips down the candle, creating a pool of liquid wax that fuels the flame. For the real-life applications or uses of melting, we have cooking. Melting is used in cooking to transform solid ingredients into liquids. For example, butter is melted before adding it to cake batter, or melted cheese is used as a topping for nachos. Next is making popsicles. Melting is involved in making popsicles. You pour liquid juice or flavored water into molds and then freeze them. When you take them out of the freezer and let them sit, the popsicles start to melt, turning back into liquid. Third is recycling. Melting is used to recycle metals like aluminum and steel. Scrap metal is melted down at high temperatures to make new products, like aluminum cans or steel beams, instead of throwing it away. Next is we have art and crafts. Melting can be used in art and crafts projects. For example, Crayons can be melted and poured into molds to make new crayons with different shapes or colors. Next we have is what we call evaporation. It is a process when the liquid turns into a gas. This happens when the liquid gets warm enough and its molecules move so fast that they escape into the air as vapor. You can think of it like tiny invisible water particles flying away from a puddle, a cup of water, or even wet clothes when they're left out to dry. Here are the examples of evaporation. We have drying clothes. After washing your clothes, you hang them outside to dry. As the sun shines on them and the air around them gets warm, the water on the clothes evaporates and they become dry. Puddles disappearing. After it rains, you might notice that puddles on the ground disappear, even if it's not sunny. This happens because the water in the puddles slowly evaporates into the air. Steam from boiling water. When you heat water on a stove to make tea or cook pasta, steam rises from the pot. This steam is water vapor, formed because the water is evaporating. For the real-life applications or uses of evaporation, we have swimming pool evaporation. Have you ever noticed that a swimming pool gets lower over time, even if nobody takes water out? This is because water evaporates from the surface of the pool, especially on hot days. That's why sometimes we need to add more water to keep the pool full. Next is drying wet surfaces. If you spill water on the kitchen counter or the bathroom floor, you can wipe it up with a towel. But what happens if you leave it there? Eventually, the water evaporates and the surface becomes dry again. Next is water cycle. Evaporation is a crucial part of the water cycle. When the sun heats up bodies of water like oceans, rivers, and lakes, water evaporates into the air. This water vapor rises, cools down, and forms clouds. Later, when the clouds get heavy with water, it falls back to the ground as rain, snow, or hail. Next is making salt. Ever heard of a sea salt? It's made by evaporating seawater. When seawater is left out in the sun, the water evaporates, leaving behind salt crystals. These crystals are collected and cleaned to make the salt we use in cooking. The next one is we have freezing. Freezing occurs when a liquid turns into a solid when it gets cold enough. Imagine water turning into ice when it's left in the freezer or outside on a cold winter day. The cold slows down the molecules in the liquid, making them stick together and form a solid. Examples of freezing. 1. Making ice cubes. One common example of freezing is making ice cubes. You pour water into an ice cube tray and put it in the freezer. The water freezes and turns into solid ice cubes as the water gets cold. Freezing popsicles. When you make popsicles at home, you pour juice or flavored water into molds and put them in the freezer. Over time, the liquid freezes, turning into tasty frozen treats. Ice cream. Have you ever seen an ice cream machine at an ice cream shop? It works by freezing a mixture of cream, sugar, and flavors while stirring it. This makes creamy ice cream that you can enjoy on a hot day. We now come to the real-life applications or uses of freezing. First is we have preserving food. Freezing is a great way to keep food fresh for longer. You can freeze fruits, vegetables, meat, and leftovers to prevent them from spoiling. This way, you can enjoy your favorite foods even if you can't eat them right away. Next is keeping cool. Ice and frozen treats are perfect for keeping cool on a hot day. Whether you're drinking a cold glass of lemonade with ice cubes or enjoying a frozen dessert like ice cream or popsicles, freezing helps us stay fresh when it's hot outside. Next one is transporting perishable goods. In places where it's hard to keep food fresh, like during long journeys or in remote areas, freezing is used to preserve perishable goods. Foods like meat, fish, and vegetables are frozen before being transported to keep them from spoiling. Next is we have making frozen treats. Freezing is essential for making all kinds of delicious frozen treats, such as ice cream, sorbetes, frozen yogurt, and gelato. These treats are enjoyed by people all over the world, especially on hot summer days. We will now proceed with the group activity. Divide the class into 5 groups. Each of you will decide on the specific role you will play within your group. Along with each role are color-coded visors with your corresponding meaning. Manager, it means red. Speaker, it means blue. Director, green. Reports coordinator, yellow. You'll have a copy of Changing State of Water. Remind your teammates of your roles. Perform the activity as directed and answer the questions provided in the worksheet. Present your output in class. For the questions in the group activity, we have: what happened to the ice cubes when placed directly under the sun? What do you call this process? What happened to the wet handkerchief when placed directly under the sun? What do you call this process? What happened to the water inside the plastic bag after leaving it in the freezer overnight? What do you call this process? Let us now check your answers. For number 1, what happened to the ice cubes when placed directly under the sun? You're right, the ice cubes will melt when placed directly under the sun. What do you call this process? Exactly, the process is called melting. What happened to the wet handkerchief when placed directly under the sun? You're right, the wet handkerchief will be dried out when placed directly under the sun. What do you call this process? Very good, the process is called evaporation. What happened to the water inside the plastic bag after leaving it in the freezer overnight? Very good. The water inside the plastic bag will turn into ice after leaving it in the freezer overnight. What do you call this process? Exactly. The process is called freezing. For day 3, chemical change. What do you think will happen when wood burns? You're right, when wood burns, it will undergo combustion, producing heat and light. The wood will break down into ash, carbon dioxide, and water vapor as it turns from solid to gas and residue. Burning is a chemical reaction that occurs when a substance combines with oxygen from the air, releasing heat and producing new substances. Observe this. What changes do you see when we light the wood on fire? Very good. When we light the wood on fire, it starts to produce flames and smoke, and it gradually turns to ash. Describe the color of the flames. Are they the same throughout the burning process? The flames are usually orange and yellow, and they can change to blue as the fire progresses. Do you notice any smoke? What do you think is causing it? You're right, yes, there is smoke, which is caused by the wood releasing gases and tiny particles as it burns. How does the wood change as it burns? Does it look or feel different? Yes, the wood changes by crumbling and turning into a lighter, brittle texture. What do you see left behind after the wood has burned completely? Very good. After the wood has burned completely, only ash remains. Can you describe the ashes? What do you think they are made of? The ashes are light, grayish, and powdery. They are made of the mineral components left after the wood has burned. Based on what you observed, do you think burning wood is a chemical change or a physical change? Why? You're right, burning wood is a chemical change because it results in the formation of new substances like ash and gases. What do you think happens to the wood molecules during the burning process? Exactly. During the burning process, the wood molecules break down and react with oxygen to form new compounds such as carbon dioxide and water vapor. Can you name any other examples of chemical changes that you have seen or heard about? Other examples of chemical changes include roasting of iron, baking a cake, and digestion of food. Here are the examples of chemical changes. First is toasting bread. When bread is toasted, it undergoes a chemical change. The heat causes the bread to turn golden brown and crispy. The high temperature of the toaster or oven changes the bread's color and texture, creating new flavors. Next is roasting marshmallows. When marshmallows are roasted over a campfire, they undergo a chemical change. The heat makes them melt and turn brown on the outside. The heat from the fire transforms the marshmallow's texture and taste, making it gooey and delicious. Next is baking cookies. When cookie dough is placed in the oven, it undergoes a chemical change. The heat causes the dough to rise and turn into cookies. The high temperature of the oven changes the dough's composition, turning it into a tasty treat. Next is caramelizing sugar. When sugar is heated in a pan, it undergoes a chemical change called caramelization. The sugar melts and turns into a golden brown liquid with a rich flavor. The sugar changes color and taste as it is heated, creating a sweet caramel sauce for desserts like caramel apples or caramel popcorn. Popcorn popping. When popcorn kernels are heated on the stove or in a microwave, they undergo a chemical change. The heat causes the moisture inside the kernels to turn into steam, which builds up pressure and eventually makes the kernels pop. The high temperature transforms the hard kernels into fluffy popcorn, ready to eat as a tasty snack. Next is frying an egg. When an egg is cracked into a hot frying pan, it undergoes a chemical change. The heat causes the proteins in the egg white and yolk to denature and coagulate, turning from a liquid to a solid. The egg changes texture and color as it cooks, becoming a delicious breakfast food that can be enjoyed sunny side up, scrambled, or fried. These examples help demonstrate how high temperatures can lead to chemical changes in different substances, resulting in new materials or products with altered properties. Let's now proceed to the lesson activity. Divide the class into 4 groups. Each member of your group will decide on the specific role you will play within your group. Along with each role are color-coded visors with your corresponding meaning. Manager means red, speaker blue, director is green, and reports coordinator is yellow. Go over worksheet number 2, titled Unveiling Chemical Transformations with Heat. Perform the activity as directed and answer the questions provided in the worksheet. Present your output to the class. Day 4. For the lesson activity, outline in the graphic organizer what you have learned in the lesson. Utilize the graphic organizer below. We have changes in materials. Under this, we have physical change and chemical change. For the correct answers, we have, for the physical change, melting is solid to liquid, evaporation is liquid to gas, freezing from liquid to solid. For the chemical change, we have the formation of charcoal, rust formation, production of smoke, formation of ash, and formation of bubbles. Physical changes are alterations in the appearance or state of a substance without changing its chemical composition. In other words, the substance remains the same at the molecular level before and after the change. It can involve changes in state, solid, liquid, gas, shape, size, or phase. Melting from solid to liquid. Melting is a physical change in which a solid substance changes into a liquid state when heated to its melting point. During melting, the intermolecular forces holding the particles of the solid together weaken, allowing the particles to move more freely and flow past each other. This results in the solid substance transforming into a liquid while maintaining its chemical composition. Common examples of melting include ice melting into water and wax melting into a liquid state when heated. Evaporation, from liquid to gas. Evaporation is a physical change in which a liquid substance changes into a gas state at temperatures below its boiling point. During evaporation, molecules at the surface of the liquid gain enough kinetic energy to overcome the intermolecular forces holding them together and escape into the surrounding space as vapor. This process occurs spontaneously and continues until an equilibrium is reached between the rate of evaporation and the rate of condensation. Common examples of evaporation include water evaporating from puddles, drying clothes on a clothesline, and the gradual disappearance of liquid perfume from a container. Freezing, from liquid to solid. Freezing is a physical change in which a liquid substance changes into a solid state when cooled to its freezing point. During freezing, the kinetic energy of the molecules decreases, causing them to slow down and form orderly arrangements known as crystals. As a result, the liquid substance transforms into a solid with a fixed shape and volume while retaining its chemical composition. Common examples of freezing include water freezing into ice cubes, liquid wax solidifying into candles, and the solidification of melted chocolate when cold. In summary, physical changes involve alterations in the state or appearance of a substance without changing its chemical composition. Melting, evaporation, and freezing are examples of physical changes that occur when substances transition between different states of matter, solid, liquid, or gas, due to changes in temperature and energy. For the chemical changes, also known as chemical reactions, involve the transformation of one or more substances into new substances with different chemical properties. It can occur due to various factors, including exposure of materials to high temperatures and mixing of different substances. Evidence of chemical change. When wood is heated to high temperatures in the absence of oxygen, it undergoes a chemical change called carbonization. This process removes the water and other substances from the wood, leaving behind a black, carbon-rich material called charcoal. Example: think of when you have a bonfire or grill marshmallows over a campfire. After being exposed to the heat, the wood turns black and becomes charcoal. Next is the formation of ash. When organic materials like wood or paper are burned, they undergo a chemical change called combustion. During combustion, the material reacts with oxygen in the air and breaks down into new substances, including ashes. Ashes are the solid remnants left behind after the burning process. Example: after you burn a piece of paper or wood, the gray powdery substance that left behind is the ash. It's what's left over when the material burns up. Third one is the rust formation. Rust forms when iron or iron-containing metals are exposed to oxygen and moisture over time. This exposure causes a chemical reaction called oxidation, where iron atoms combine with oxygen atoms to form iron oxide, which appears as reddish-brown rust. Example: you might have seen rusty nails or metal objects that have turned reddish-brown after being exposed to air and moisture for a while. This is because the metal has undergone a chemical change and turned into rust. Next is formation of bubbles. Bubbles form when a gas is produced during a chemical reaction. This happens when two or more substances react chemically, producing a gas as one of the products. The gas forms bubbles that rise to the surface. Example: when you mix baking soda and vinegar together, bubbles form because a chemical reaction occurs between the two substances, producing carbon dioxide gas. Next is production of smoke. Smoke is produced when materials burn incompletely, leading to the release of tiny particles and gases into the air. It occurs during the combustion of organic materials, such as wood, paper, or fossil fuels. Example: when you light a campfire or a candle, smoke rises from the flames. This is because the materials are undergoing combustion, and smoke is produced as a result. For your reflection on learning, each of you must have pencils or markers. Draw two large circles on your paper, labeling one circle physical changes and the other chemical changes. Think of examples of physical and chemical changes you have observed or learned about. You can write or draw these examples in the appropriate circle. Let us now proceed to the formative assessment. Number 1. Which of the following is an example of a physical change? A. Burning wood. B. Rusting iron. C. Melting ice cream. D. Baking a cake. You're right. The correct answer is letter C. Melting ice cream. Number 2. What happens when you tear a piece of paper into small pieces? A. A chemical change occurs. B. The paper undergoes evaporation. C. The paper undergoes a physical change. Or D. The paper undergoes sublimation. You're right. The correct answer is letter C. The paper undergoes a physical change. Number 3. Which of the following is an example of a chemical change? A. Cutting vegetables. B. Melting butter. C. Mixing baking soda and vinegar. You're right. The correct answer is letter C. Mixing baking soda and vinegar. Number 4. Sarah was cooking scrambled eggs for breakfast. She cracked some eggs into a hot frying pan and stirred them until they were cooked. What type of change did the eggs undergo during cooking? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. You're right, the correct answer is letter B, chemical change. Number 5. Timmy mixed some sugar into his glass of water until it dissolved completely. What type of change occurred when the sugar dissolved in the water? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. You're right, the correct answer is letter A. It is a physical change. Number 6. Which of the following is an example of a physical change involving a change of state? A. Rust forming on an iron nail. B. Paper burning and turning into ashes. C. Ice melting into water. Or D. Milk spoiling and curdling. Exactly, the correct answer is letter C. Ice melting into water. Number 7. Maria was baking cookies in the oven. As the cookies were baked, they turned golden brown and became fair. What type of change occurred to the cookies during baking? A. Physical change. B. Chemical change. C. No change occurred. D. Both physical and chemical changes. You're right, the correct answer is letter B, chemical change. Number 8. Alex lit a candle and observed as the wax melted and formed a pool of liquid around the wick. What type of change occurred to the wax during burning? A. Physical change. B. Chemical change. C. No change occurred. Or D. Both physical and chemical changes. You're right, the correct answer is letter A, physical change. Number 9. Jason was cleaning his bicycle after a ride. He noticed that the metal parts were starting to rust. Why is it important for Jason to prevent rust from forming on his bicycle? A. To make his bicycle look shiny and new. B. To avoid damaging the metal parts of his bicycle. C. To impress his friends with his well-maintained bicycle. D. To win a prize for the best-looking bicycle. You're right, the correct answer is letter B, to avoid damaging the metal parts of his bicycle.